Are you starting? Okay. We're recording. So, to start over, we were putting this into slope-intercept form, okay? So this is how it was given to us. We needed to move the x term to be over here because we want y by itself. So y is greater than or equal to negative 4x plus 3. Now, is this in slope-intercept form?
Yes.
Yes, okay. So I think the thing that is making you guys confused is that the graphing part of this is no different than if it was y equals negative 4x plus 3. So we're going to graph, when it says graph this, okay? So we graph it, and this is before I can answer any question because I want a visual. So I'm going to graph the actual equation. Now, how do I graph it in slope-intercept form?
Where do I start? You start at 3.
You start at 3.
Start at 3. 1, 2, 3. On the y-axis. Then how do we continue?
Go down 4.
Thank you, Hannah. Go down 4. And to the right 1. Okay, because you always go to the right for the denominator. So we don't need any more than 2 points. Okay, so that's graphing. Now, the only difference between graphing an equation and graphing an inequality is now we have to think about, is there a solid line or a dashed line?
Ooh.
Solid.
Yasmin?
If there's a line underneath, then it's a solid line.
Okay, so if there's an equal to line, which there is, it's a solid line. If there was no equal to line, okay, it would be a dashed line. Okay, but this one is a solid. Whoops, and it should be straighter than that. Going through those 2 points. Now, the next part that's different than graphing a regular equation is the shading. Okay, so these are the 2 things you need to keep in mind, the type of line and the shading. Now, how does the shading work? We need to pick a test point. What is the popular test point?
0, 0.
0, 0. Okay, you can use 0, 0 almost every time. The only time you can't, like one of the ones in the warm-up, is if your line goes through 0, 0. Then you just pick a different one. Okay, but as long as it doesn't go through your line, you can pick any point. We're going to use 0, 0 to plug in y for 0, or 0 for y, and 0 for x in my inequality. Okay, and what I'm checking is I'm checking to see if it makes a true or false statement. Does this make a true or false statement?
False.
This is false because 0 is not greater than or equal to 3. So what I do with this information is I go to my test point, and if it's false, I'm going to shade from my line away from the test point. If it's true, I would shade from my line towards my test point. So in this case, it's false. So I'm going to take from my line and shade all the way on the other side of it, okay? Nothing towards 0, 0, all the rest of it, okay? But notice that I don't pass over my line, okay? I'm either going to go this way or I'm either going to go this way, okay? Depending on whether the test point is true or false. Does that make sense? Okay, now that's just the basic graphing part of it. What the question was asking, and the reason why I needed the visual, is because we need to see which ones are not, or which one is not true. Okay, so I would just go through and see. The 0.34, is it located in the shaded region?
Yes.
Well, 3, 4, yes, right? So yes, so that's not true. I mean, that is true. B, the boundary is graphed as a solid line. That's true. It's a solid line, okay? The boundary, what they mean by boundary is just the line. The boundary is graphed along y equals negative 4x plus 3.
True.
Well, yeah, once we put it into slope-intercept form, that's what it is. And so D, the origin, which is 0, 0, another word for it, is located inside the shaded region.
True.
False. So that one's the one that's not true, okay, D. But it's the best way to do it is to just make sure that you have a visual first. Any questions on that one?
No.
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 Okay. Next one.
Oh.
This says determine whether the test point 2, 2 is in the shaded half plane of the graph. Now this one, again, here's the equation they give me. Is this in slope-intercept form?
No.
No, we need to move the 4. So we have y is less than or equal to 5x minus 4. Okay, and that's what we're graphing. Okay, so we need to graph this as y equals 5x minus 4. So that tells me to start
-4.
at -4 on my y-axis. So 1, 2, 3, 4. And then how do we continue? Thank you, Yasmin. 1, 2, 3, 4, 5. Up 1. Okay, now we need to figure out what type of line we have. Solid or dashed? Solid. Then we need to figure out, okay, 0, 0 we can use as a test point, so I'm going to use it. Now we need to plug it in to find our shaded area. So we have 0.
This is awkward. Going in circles.
Okay, or not. Okay, 0, I needed to think, is 0 minus 4, so that's -4. So is 0 less than or equal to -4? That is also false. So here's 0, 0, shade from the line away from it. Oops, don't go on over the line, okay? So make sure it's from the line away if it's false. So now we can look at it. Is the test point 2, 2 in the shaded area?
Yes.
Yes. Okay, so that's 7 is yes. Okay. Now 8. 8 is just a fancy way of saying graph. Okay, it says use a graph to solve. Just graph it. Okay, what it means by that though is notice that the graph or the equation has only x. But we're going to graph it. What that means is to be able to graph this, even with just one variable, we need to have that variable by itself. Okay, so we need to actually solve for x first, and then we're going to graph that. Okay, so we subtract 2. That's less than or equal to -1. Yes, Joseph? No. Then we multiply by 2 over 1. And we get x is less than or equal to -2. This is what they want you to graph for number 8. Okay? So, how do we graph when it's just one variable? So let's say, how would we graph x equals -2? Michael?
You graph the intercept.
Okay, so you go to 2, or -2, on the x-axis, and you put a point. Now you have to have a line, so what type of line? Is it solid or dashed? Kishore? Solid. And it's going to go through the x-axis. It's going to go right up and down like that. Okay? Now, we can still do the same thing with the test point. We just need the 1, 0. So, is 0 less than or equal to -2?
No.
Again, false. Okay. Again, false. So here's 0, 0. We shade away from 0, 0. And that is really all it's asking us to do. When it says use the graph to solve, it's just asking us to graph it. So we're going to just graph it. Questions on 7 or 8? Asa?
Yes. No.
Okay. Now, 9 and 10, notice 9. 9 is almost the exact same as 8, except for we have less than +2. Okay, so we're going to still graph x equals 2, but it's going to be, for the test point and the shading, it's going to be, we need to pay attention that it's less than 2. Okay, but we go to 2, okay, since we have x equals 2. And what kind of line is it, Abner? No. What kind of line is it?
Vertical.
It's a vertical, but dashed or solid? Dashed.
It's an emergency.
Okay, so 0 is less than 2. We need a test point. Is 0 less than 2?
Yes.
That one is true. So this one, you shade towards the 0, 0. Okay, all this part. But again, you don't want to go past the line. All right, one more. The hardest part about this last one is just putting it into slope-intercept form, okay? Or realizing that it needs to be. Okay, so how would you put this into slope-intercept form?
Well, you have to distribute.
You have to distribute. So you have negative 4x plus 4y. And we need to get y by itself, for sure.
Add 4x.
Add 4x. So we have 4y is less than or equal to 4x plus 8. Rachel?
Divide by 4.
Divide by 4. And you have to divide everything by 4. So I didn't do any dividing by a negative, so my symbol still stays the same. That's going to be 1x or x plus 2. This, see how different that looks than that? Okay? Your graph would be a lot different if you're trying to graph this in comparison to this. So make sure it's in slope-intercept form, and then we graph it. So we're going to graph y equals x plus 2. Oops, it didn't work. And we go to 2. We go to 2 on the y-axis. Our slope is 1. So we go up 1 over 1, up 1 over 1, okay? And what kind of line is it?
Solid.
Solid. We can use 0, 0. So 0 is less than or equal to 0 plus 2 or 2.
True.
True. So here's 0, 0. We're going to shade all that. And that's our answer.
Can please use about
You
that?
both can go to the bathroom. You can stop the video.
Video credit by
Go to the
Rachel.
bathroom.